Hello everyone, welcome to my channel. Myself Ignesh Anand. In this video we are going to see about the single phase AC induction motors, their principal operation, which means working, their constructions and their types. So coming up to the topic. So normally a single phase AC supply is used as an input for operating this induction motors. Then second thing is that it works on a principle of electromagnetic induction like a normal motor. So the single phase AC supply, which is produces a torque, and the torque is produced by the alternating magnetic field. So a large number of domestic applications are used for your single phase induction motors like fans, toys, then for hair dryers. This is some of the example which we are using in your day to day life. Then the induction motor never rotates with the synchronous speed, which means it will be rotating in a speed lesser than the synchronous speed. And this single phase induction motor are not a self starting motor, so we need some of the external support for initial starting of your motors. Next, coming up to the working principle, for the motoring operation there must exist two forces, which means two fluxes, which will oppose each other and produces a torque. One of the force was or the flux was created by your stator, and second one was from your rotor. Then a single phase supply AC supply is given to your stator winding. So the stator winding carries an alternating current which produces the flux, which means your rotating magnetic field. This flux is your main flux. This flux links with the rotor conductors, and due to the transformation action, which means due to the electromagnetic induction principle, EMF get induced in the rotor. So that EMF induced will carry some of the current to the rotor, as the rotor circuit was closed circuit, which means the rotor was connected to the load, so it will be in a closed circuit. So this rotor current produces another flux called rotor flux. So thus the second flux is produced, and according to this induction principle, this second flux will be opposing your stator produced fluxes, and then further the torque is been created. As I said, the single phase induction motor, AC induction motor, is not a self starting motor, so we need some of the uh, analysis for their rotation, which means for their operation. One of the main analysis is your two types of theories. One is your double revolving field theory, and the second one is your cross field theory. So a double revolving field theory, in the sense the pulsating magnetic field is resolved into a two rotating magnetic field, which means it will be separated into a two revolving magnetic fields. They are equal in magnitude but opposite in a direction. So the induction motor responds to each of the magnetic field separately, and the net torque in the motor is equal to the sum of the torque due to the each of these two magnetic field which is produced. Then coming up to the cross field theory, according to the cross field theory, the stator flux can be created into a two components which are mutually perpendicular. One act along the axis of the stator winding, and the other act accords to the perpendicular to it. Now assume that an initial push is given to the rotor in an anticlockwise direction. Due to the rotation, rotor physically cuts the stator flux, and dynamically EMF get induced in the rotor. So this EMF circulates current through the rotor. This current produces its own flux called rotor flux at an angle of 90 degree to the axis of the rotor flux. Hence the rotor flux is called the cross flux. So these are all the two theories for your self-starting operation. Then coming up to the construction of your single phase induction motors. So normally, as a common symmetrical type or a three-phase types of a motor. This also carries a two main parts as a stator and rotor. Stator is your static part and the rotor is your rotational part, a rotary part. In stator, we will give the single phase AC supply, which means the input supply in the stator windings. Then motor has a laminated stampings to reduce eddy current losses on its periphery. So the stator slots are provided on its stamping to carry the stator or the main windings. The rotor is your rotatory path in which it connects with your load end. The rotor is like a cylindrical squirrel cage type of rotors. In here, single phase AC induction motor, we will use a squirrel cage type of rotors. The slots are not made parallel to each other but are little bit skewed position, so in order to prevent from the mechanical locking of your stator and rotor slots. Then other peripherals will be there. This is the overall construction of your single phase induction motor. So as I said, the stator and the rotor will be inside your yoke or a frame. Next, stator windings. Stator windings and the connecting terminals, which means your input wirings which need to be done, that's also been mentioned. Then your rotor. In here we are using the squirrel cage type of rotors, so that's why I have using the squirrel cage type of, which means the cylindrical type of rotor constructions. Then the fans blades are been connected at your rotor area, which means rotor end, in order to reduce the heat produced by the rotors. Then the end terminals to close the frames of your motor. These and all comes in your overall construction of your single phase induction motor. Then why your single phase induction motor is not a self starting motor? The main reason is that when a single phase supply is given to its stator winding, it produces a flux which is only a alternating kind of flux. So it is not synchronously revolving flux as like a two or three phase stator windings. So now an alternating or a pulsating flux acting on a stator or the stationary squirrel cage rotors, it cannot produce a rotation, which means the squirrel cage rotor will not get a proper torque for the initial movement. So for that movement, we are carrying out some of the methods for making it as a self-starting motor. To make a single phase induction motor as a self-starting motor means, first we have to temporarily convert it into a two-phase motor, which means during at the starting period it should act like a two-phase motor. So for this purpose, the stator of the single phase induction motor is provided with a extra winding, which is known as a starting or a auxiliary winding in addition with the main or the running windings. So the the two winding are a 90-degree electrically displaced and are connected in parallel across the single phase supply. So it is arranged in a phase shift between the current in the two stator windings, which means your main and the running windings, auxiliary winding. So the current in between these two winding will be very higher than your ideal value. So automatically there is an torque will be produced in accordance with this phase shift, and hence the rotor get moved in the initial time, which means at the time of starting. Next, coming up to the types of single phase induction motors and how they are divided. So a single phase induction motor uh, which is splitted into a three types, but practically there are four types. uh, Split phase type, which means that the split phase type will be further subdivided into a capacitor start, capacitor run, capacitor start and run, like kind of a thing, then shaded pole, reluctance type, then permanent magnet type. So these are the main types of your single phase induction motor. Then types of induction motor, as I said, resistance start, capacitor start, permanent magnet, capacitor start and run, then shaded pole. These are all the examples of your types and their motor classifications of your single phase AC induction motors. Next, coming up to the advantages. The main advantage of your AC induction motor is that it is a very less expensive, and different types of the motors can be uh, according to their size variations. We have different types of motors. Then the working of the motor is independent of your environmental condition. This is because the induction motor is robust and mechanically strong. Then a squirrel cage induction motor does not contain any of the slip rings or brushes, so automatically your cost of the equipment get reduced. Then due to this absence of brushes, there is no sparks will be produced in your motor. Hence it will be safer for your usage. Then uh, the main disadvantage is that it is having a low starting torque, so we need to provide we need to take care of your initial starting of your induction motor, which means it is not a self starting, so we need some extra care for that. It is more loose and having a poor efficiency comparing with the other motors. Then the direction of the motor cannot be reversed once it get charged, means then it is having a low power factor automatically. The low power factor, uh, in the sense the controlling of power factor is very very not possible kind of thing in your single phase induction motor. Then as you know that they are dependent of the load. If the load current is get increased, means automatically your efficiency of the motor will be get reduced. These are all the main disadvantages of your single phase induction motor. Then coming up to the applications, it is mainly used in your household kind of equipment like fridges, fans, air conditioning, vacuum cleaners, washing machine, centrifugal pumps, tools, then small farming applications, then for your blowers, hot air blowers. Then these are mostly used in your low power and for low power, but the speed of the motor will be in a constant, in the sense uh, the constant speed is maintained by the constant load, which means we need to keep power factor in a constant level, so that the speed can be maintained in a constant level, and automatically it can be used in your many of the agriculture tools by this kind of way. Hope you have understand, I think so. See you in next video. Have a nice day. And coming up video, we'll have a small discussion about the uh, types of AC induction motors. Have a nice day. Nandri, vanakkam.